Meeting is being recorded. Dr. Amit, if you want to start with introduction, please go ahead.
Yeah, we can start.
Dr.
Yeah.
Amit
Yes,
Kumar,
yes,
will
sir.
introduce you.
Am I audible, sir?
Yes, you
Yeah,
are.
yeah.
Please
Okay.
go ahead with the introduction.
Okay. Okay. So first of all, good morning to all the delegates and participants of this 21 days national refresher course. So I would like to today we have the resource person for today's lecture, Dr. Amit Kumar Pandey. So first of all, I would like to introduce him. So there is a brief intro of Dr. Amit Pandey. He bears the research interest in the area of machine learning, mediated drug and vaccine designs. Currently, he is investigating on prophylactic and as well as the therapeutic for LSD and canine parvovirus. Actually, I would like to say he considered as a very good researcher of our industry. So earlier he has investigated synthetic legends including aptamers and magnetic integrated polymers, designing and application of the antibacterial peptide to combat antimicrobial resistance. This for Cas9 to develop the Pseudomonas aeruginosa vaccine and loop mediated isothermal amplification of DNA. He has developed rapid and field deployable technique for the authentication of the camel milk and identification of the multiparous seed animal. He has published 25 articles in Journal of International and National Report and 4 patents filed in his career related with the diagnosis and therapeutic purposes. So I would like to welcome Dr. Kumar Pandey on the behalf of all the participants or also request for the starting of the or the deliver your presentation, sir. Dr. Amit Kumar Pandey, sir. Over to Pandey, sir.
Uh, First of all, I'm very thankful to Dr. Amit for a very good introduction and gave me the opportunity to discuss about biodefense, reimagined, cutting edge approach, and advances. So, we will speak about firstly about biodefenses and then how technology can be used to combat these threats nowadays. We are facing the current scenario. So we will discuss some of the rational points. Then we have will go through. Then we will go through certain points about the reprogramming of drugs and then procedure and examples, then epitope mapping and vaccine designs, procedures and examples. All right. So regarding the bio threat, so this bioterrorism can be defined as it refers to the intentional release of biological agents or toxins for the purpose of harming or killing humans, animals, plants, to intend and to intimidate or to make generate fear among the government and civilized civilian population to cater their political and social objectives. So this is how the Interpol defines the bioterrorism. So we have seen that several of the enemy countries they have used anatoxins, excitotoxins, and tetrodotoxins, and they have added these things in the marine water, and so as to intimidate the people or civilian population. In fact, this incidence of bioterrorism is not a new. A book was written by a Chinese military clinician, Zhu Denzong. So he has written a book on unnatural origin of SARS and new species of man-made viruses as genetic bioweapons. Uh, this book was earlier available on Amazon. After 2015, no, it has been withdrawn from Amazon by the Chinese government intensely. So it is all known. It is all these people all knew that SARS could be the regenerated virus and mutated virus to spread bioterrorism. Moreover, in the area of this, you can see the Tibet area. You can observe this. Here, these Chinese people have implanted silver nitrate plants to emit silver nitrate fumes so as to create artificial rain in that area. So we all have witnessed several slots of rain, unusual rain in Uttarakhand and all the above areas. And we will we'll look further this cyclones also in later slides. So this weather war is not a new thing. Earlier, US military has used cloud seeding to make mud so that Vietnam military vehicles cannot move. So this was termed as Operation Popeye by the US military. So this term I firstly encountered with an article of a UK visiting professor Aparna Roy. So she showed courage to define the word weather war and how Chinese people are harming the other countries by creating cloud seeding and artificial rains. So this is just raw data I have collected uh, from 1940s till 2020s. So I have collected the data of these are the cyclones these are the recent cyclones, Fangal, then Dana, Asna, Remal. These are the cyclones of 2024 itself in the subsequent months. So, this one, October, September, October, November, like that. So daily, every month, one cyclone is coming. In the right hand side, you can visualize several of the drugs I have listed. So these are the drugs, diseases. These are the diseases we have came across and recently, and these are not usual diseases which occur. So doesn't it be suspicious to you people? I think it is. So this I have plotted the graph. So combining these two data from meteorological department and health department, the graph is increasing decade by decade. You can visualize. And it was actually around a plateau phase up till 1990s. And in 2020s, it has shoot up. In the 2010s, it has again gone up. Then in 2020, it has crossed the half, and definitely, and only 4 years have gone for this decade. Definitely, it will cross this limit also. So these things could be suspicious and should be taken as challenge. And what we require is we are from health sciences and we can tackle these diseases of animals as well as human beings. We are tackling, but all those things that drug development and vaccine development requires hell lot of time. So there are several machine learning tools which we'll be discussing in this presentation. It has this is machine learning is a subset of this machine learning is a subset of artificial intelligence algorithms. It consists of algorithms and backed up with certain data submitted in repository. Uh, Now, third point, these tools expedite the research regarding vaccine and the drug development, that is immunogenic peptides from pathogens for use in nucleic acid based vaccine construct and screening of effective drugs, that is reprogramming of drugs. So this term reprogramming is not a new probably after the onset of this COVID-19. We all have observed the use of ivermectin. Ivermectin. So this ivermectin in the left side, this I'm sorry, this mouse is not working, I think. Okay. Anyway, on the left side, you can visualize the photograph. In the cytoplasm, what happens is this COVID-19 virus enters and it binds to the important proteins, that is alpha and beta, and then it can enter into the nucleus. So, in the effect of ivermectin, this complex with the COVID-19 virus and IMP alpha and beta, they cannot bind. They cannot bind and they cannot enter into the nucleus. So, this was the mechanism behind this uh, this mechanism behind uh, the use of ivermectin actually. So, people have observed on the right side, you can see several of the graphs which say that ivermectin has decreased the virus replication rate or viral infection subsequently. So this computer-aided drug design has several of the steps. Like firstly, we need to understand the genomics of the disease. We need to have good information of that disease, and then we out of that information we select a target, uh, and with that target we use to for docking of the several of the drugs. Then target validation, whether that target can act as a real target or or just it we need to work on that target or we need to change that target. Then fourth one, we can out of the several drugs, we can get a one drug out of that drug, that is called lead discovery. Then we have to optimize that drug uh, to have better binding of the target and the drug. Then we enter into preclinical and then clinical trials. So several of the steps we will go in detail of this computer-aided drug design. So this the drug whatever we come across and we screen should follow the Lipinski rule of 5. So this is the Lipinski rule. Its molecular weight should not be beyond 500, and the clock p value, some of the parameters like clock p value, it should not be more than 6. Then hydrogen acceptors should not be more than 10, and hydrogen bond donors, it should not be maximum limit is 5, and TPSA parameter, it should not be beyond 120. So this is the Lipinski rule. This is Lipinski rule of 5. All those drugs which follow this rule of 5 will be given preference in the drug designing. So several of the workers, they have followed similarly. They have firstly selected the target and downloaded the 3D structure, and then they downloaded the drugs from Selechem.com. The Selechem.com and other NCBI drugs, these are the databases which can store drugs, and we can retrieve the names and structures and SDF files of these drugs from Selechem.com. So then we can have virtual screening. This virtual screening may utilize several of the softwares like MPro. It includes docking, high throughput docking between target, our proteinaceous target, and the drug. Here I would like to mention that this target is several times should be taken as a vital protein like transcription factor or some polymerase. So which is very crucial for replication of virus or bacteria, whatever it is. So after virtual screening, these people have got several of the good results like Intinavir, Atazanavir, and Lopinavir. So I would like to mention that this in a rabies virus also, these people have tried drug designing, taking RNA dependent RNA polymerase. So they have downloaded the sequence from NCBI. Then homology modeling through Swiss model. They will design a 3D model. and then virtual screening using gold software. Earlier they have used MPro. Here they have used Gold. We utilize Pyrex. There are good number of softwares freely available. You can download and you can start virtual screening with that. So they can shortlist the drugs out of several thousands of the drugs. So people have tried with dengue virus also, taking NS5 DNA, RNA dependent DNA RNA polymerase as their target in the similar way. All these protocols are same. However, uh, and moreover, they have got good results. People have tried with anti-influenza virus A compounds among the medicines. Then people have tried with SARS-CoV-2, that is COVID. They have tried with several of the proteins, then virtual screening by FLAP software, and they can get the result easily. One must go, all those articles are similar. So, how this can be done? What is the protocol, exact protocol behind this? So what we require is, I told about NCBI database. Then we need to have protein data bank from downloading the 3D structure of the protein. And if the protein data bank doesn't suggest any protein structure, we can go for Swiss modeling also. This Selecam provides the data. It is a database for drugs, and it has more than 1 lakh drugs. Out of those, around 6 to 7,000 can be screened easily in a month. So tools what we can utilize is Pyrex is a virtual screening software which is freely available, and it can be used for computational drug discovery. It actually based on high throughput docking of a target with the drugs. Then we can visualize the structure through PyMol or Discovery Studio. And this PKCSM can be, it is an in silico approach which can be used for several of the study the pharmacokinetic properties like ADMET and all. So how it is done? So we need to select some of the vital protein of that virus or bacteria that can be RNA polymerase or transcription factor. This can be obtained from NCBI, and 3D structure can be drawn, obtained from RCSB PDB. Else, if its structure is not available, we can go for homology modeling. It is very simple. Homology modeler, you can simply type on Google homology modeling. One of the server comes, and you can open that server, and you can paste your query sequence and submit it. Click the submit button, and it can be easily. It will take time to draw that model. Then this protein modeling we have, it is in detail. This we have already discussed. So then active site determination, where the drug can be bound. So that is determined by PyMol, and then virtual screening by Pyrex. It is based on Python prescription virtual screening tool. And drugs can be downloaded from Selecam, and through Pyrex we can submit those structure of our target as well as drugs and go for virtual screening. Then the drugs shortlisted, the drugs with good binding, that is minimum energy, showing the minimum energy value, uh, that those are subjected for ADMET analysis. So there is a tool. Then we can go for molecular docking, pharmacophore modeling, that by using Pharmit and ADMET through PKCSM. So people used to fear that your in silico method won't work. So what we did is we tried it for lumpy skin disease, and we selected transcription factor RNA polymerase 30 as our target, and we screened around 6,300 drugs through Pyrex. Then the drugs subjected to ADMET analysis, and we obtained 18 drugs. We shortlisted to out of 6,300. We reduced the number to 18. Then out of those, the databases we selected was antiviral drug, natural drug, and already FDA approved drugs. So we have got 5 drugs from antiviral database, 11 from natural drugs, and 2 from FDA approved drugs. Another set of 16 exhibit good binding energy, that is less than -9 kilocalorie per mole. So we have gone for modeling. We have gone for docking to obtain how hydrogen bonds and hydrophobic bonds are formed. Then we have gone for in vitro experimentation to inhibit the virus growth. And we 3 drugs we have tried, and one of the drug, that is drug 3, is giving encouraging results. We have 30 more drugs in our bag. We have to try those drugs in near future. So this is a very good area. People are trying to cater the society for to combat the oncoming outbreaks. So next, how this vaccines can be designed using ML tools. So this is the workflow of the vaccine design. Firstly, we need to download the proteome of any of the viruses. We have taken LSDV as an example. Then we have got suppose 156 genes of LSDV, and we have subjected all those 156 genes for antigenicity, whether these are antigenic or not. Then the third step, we have gone for testing of its allergenicity, whether or not it is allergenic or not. So that protein should be antigenic and it should not be allergenic. Then those proteins were subjected to a TMH-MM tool to predict the transmembrane regions. So the region outside the membrane should be selected, should be given preference in the vaccine construct. Then fifth point, we have gone for physical and chemical parameters using ProtParam tool. It is available on XPACY. Then we, whatever the proteins which got selected out of antigenicity, allergenicity, transmembrane, and physical property, we have gone for B cell epitope prediction and then T cell epitope prediction. B cell epitope prediction on the left side, 6th point, and 7th T cell epitope prediction on the right side. On both the sides, we proceeded for several of the operations. Like in B cell, we have searched for linear or continuous B cell epitopes. Then we have gone for discontinuous epitopes. And in the T cell, we have gone for MSC and MSC1 and MSC2 T cell epitope predictions. So then whatever the peptides epitopes we have obtained, these are subjected for 8th point immunogenicity, physiochemical properties again, secondary and 3D structure prediction and validation. Then it can be the peptide after breakage can be allergenic. Maybe it has lost antigenicity. So all those things have been tried again. Then whether the peptide selected screen it produces this thing. It evokes cytokine production or not. So we have gone for several of the tools like IFN pred, IL-10 pred, IL-6 pred to select those molecules. So whatever the proteins peptides are selected, then those are clustered. Clustered means if the sequence is similar, that similar sequence can be taken once, and we can take the both the proteins together. Then we can go for anti-simulation and cytokine production. So how we did is we opened the NCA, and then we have selected the nucleotides or proteins. This is the protein. This is the protein we selected. Then we have gone for the second antigenicity tool. This can be, I have given the server's website address over the right side. So Vaccine version 2.0 have this one box, which can be utilized for the sequence submission, and it asks several of things like from where this protein is. So it was from virus, and we determined some threshold. We took it as a default 0.4, and then we can submit. So all these servers are worked on similar. It will have a box. It will ask 2-3 questions about the sequence, and it will decide threshold jointly, or it can be taken as default, and then we can submit. So it gives the result like this. Uh, Overall prediction for the protection antigen 1.66. So it is giving very good antigenicity. So threshold it was taken in this experiment was zero point 0.4. So antigen it was again antigenicity was evaluated through another alternate tool, that is Scratch proteomics. So we need to enter the email, some of the sequence, and this antigen pro we can select, and then we can submit, and the result will be delivered on the email, like it is antigenic or predicted probability of antigenicities. It will
Hello.